Right, let's see what Becky's got for us here. We've got our second question. The diagram below shows different phases in meiosis of an organism. So we know meiosis is because all these questions are meiosis. So yeah, definitely meiosis. Right. So we look, I'm going to use a different color here. We diagram 1, diagram 2, and diagram 3. Now people, just what do we see here? We've got a double row of chromosomes. Can you see them? Double row of chromosomes lining up at the equator. Okay. And if they're lining up at the equator, this is how you remember it. You have prophase is your prep phase. Okay, that's where all the preparation, the crossing over, etc. Then, so prophase, metaphase, anaphase, and telophase. So how do you tell the difference? Metaphase, everything is in the middle. Anaphase, they are pulling away. Okay, so prophase, prep phase. Metaphase, middle phase. Anaphase, pulling away. So A for anaphase, A for away. And telophase is your terminal phase. And terminal means the end. So it's your end phase. All right, so T, T. And how would you know if it's prophase 1 or 2? Prophase 1, you've got crossing over. You can't miss it. Prophase 2, there's no crossing over. Prophase 1, you're going to see your homologous chromosomes are going to be sort of next to each other. And in prophase 2, not. Okay? If we look at the metaphase, easy peasy to identify 1 and 2. In 1, you've got a double row of chromosomes. Why? Because of your homologous chromosomes. They make 2 rows at the equator. Whereas in metaphase 1, there's only 1 row. They're individual chromosomes. All right? Then, anaphase, they pull away. So anaphase, the spindle fibers are now pulling towards the poles. Okay? They pull. So pull away. Anaphase for away. And what happens? In anaphase 1, you're going to have whole chromosomes. They look like little butterflies or little moths. And they pull away. So it's a whole chromosome. Whereas when you look at anaphase 2, they look like little boomerangs. Why? Because the chromatids have split at the centromere and the little boomerangs have pulled sideways. Okay, those are your daughter chromatids. All right, now, all your chromosomes. And then, if you look at here, immediately you should be able to identify our thing. This one is definitely metaphase 1. Why? Look, our homologous chromosomes are lined up here at the equator. In diagram 2, what do we see here? Now, you see these chromosomes? They're about to cross over. Now remember, there's no crossing over in in prophase 2, so it must be prophase 1. Okay, why? Crossing over hasn't happened. How do we know? If there was crossing over, you'd see bits and pieces of color from the different, that have been swapped over from the different chromosomes. Look here. You see here, these are all dark blue and the little light patch over here. And there's a little light patch over there, and they're the little dark patches over there. Do you see these guys? All right, so crossing overs definitely happened here. Which means if crossing over took place here, it hasn't happened here yet. All right, so prophase 1. And then this diagram, look, they all lined up at the equator again. And if they lined up at the equator, what have we got? It is metaphase, because they're in the middle. But how many rows of chromosomes do we have here? There's only 1 row. Here we have 2 rows. So this 1 row means that it is metaphase 2. And that is how you are going to tell whatever these diagrams are, and you are going to get 100% for this. Alrighty, let's look at our labels. 1, so A is going to be a cell membrane. I've got no more space to write anything. In fact, let's just get another color. And if I put my glasses on, I can actually see. So A is the cell membrane. Okay. B is going to be your homologous chromosomes. And just to recap, homologous chromosomes, one chromosome from dad, one chromosome from mom. And they are for the same characteristics, okay? So homologous chromosomes, there these little homologous chromosomes are. And C is a chromatid. Okay, now remember, a chromosome has a centromere, 2 chromatids. And here, what have we got? Those are our spindles. Alrighty, let's look at our questions. Label A, B, and D respectively. So A, cell membrane. Okay, and B was, oh, there we go, homologous chromosomes. Okay, and it was D, spindle fibers. Okay, and D, spindle fibers. Something else I want to just quickly show you here. Do you see these points there where the spindle fibers come from? That is called a centriole. Be careful that you don't confuse the centrioles with the centromeres that are in the center of a chromosome. Centromere, think of it that it keeps them both together. It is mere, together, all right? Whereas centriole is where the spindle fibers will come from. Okay, next question. Give 2 observable reasons why chromosome B above is regarded as homologous. Well, let's see. B above, why is it homologous? Come, why would it be homologous? They are the same size. They're the same shape. They're the same length. And the centriole, which is between the 2 chromatids, the centriole is in the same position. Okay, I've given you 4. They only wanted 2. Okay, but it's the same size, they're the same shape, they're the same length. The centriole is in the, the centro. You see, I've just done it. It's the centromere, not the centriole. Whoa. And this is just exactly what I've just warned you about. It's the centromere. Oh, yeah. All right, don't do that. Don't do that in an exam. So the centromere between the 2. All right, and if you look at the chromosomes, chromosome number 21 is the largest of all the chromosomes, and 21 is the smallest of all the chromosomes. They're all different sizes, but they carry the same characteristics. Identify the phase shown in 1, 2, and 3 respectively. Well, I remember them. 1 was metaphase 1. Okay, 2 was prophase 1, and 3 was easy. That was metaphase 2. Give a reason for identify diagram 3. Remember, I told you, what is our reason there? Is that we have a single row of chromosomes at the equator. So, single row of chromosomes at equator. And I'm running out of time here. I'm going to rush. And it says, give 2 events in meiosis that contribute to genetic variation. That's easy. We have crossing over at prophase. Which prophase? Come think. Prophase 1, because there's no crossing over in prophase 2. And we have random arrangement of chromosomes during metaphase 1 and metaphase 2. Okay, so those chromosomes, as they line up on the equator, you're going to have, let's say your chromosome pair in metaphase 1. I'm going to be finished in 1 second. You've got your chromosomes. So in chromosome pair 1, this chromosome will pull that to that pole. This one pulls to that pole. In chromosome 2, this one goes that direction and that one goes that direction. So it's all random. And that is what gives us our genetic variation.